Hello everyone. In this video we will learn about the symmetric forms or symmetric functions of zeros of a quadratic polynomial. We already know about a quadratic polynomial, that a polynomial of degree 2 is a quadratic polynomial and its standard form is ax square plus bx plus c, where a, b and c are known as its coefficients and the constant terms. Suppose the zeros of this quadratic polynomial are alpha and beta. Let alpha and beta be the zeros of px. Then we have already learnt that alpha plus beta is minus b upon a, that is minus coefficient of x upon the coefficient of x square. We have also learnt that alpha into beta is c upon a, that is the constant term upon the coefficient of x square. We have already learnt in the previous video about this relation between the zeros and the coefficients. Now we have to learn about the symmetric forms. Suppose we have some expressions like alpha square plus beta square, 1 upon alpha plus 1 upon beta, alpha upon beta plus beta upon alpha, alpha cube plus beta cube, etc. These are known as the symmetric functions or symmetric forms of the zeros of quadratic polynomial. So what is the meaning of a symmetric function or symmetric form of zeros of a quadratic polynomial? We can see here in each, if alpha and beta are interchanged, the expressions remain same. So we can say an expression in alpha and beta such that the expression remains same, or we can say unchanged on interchanging the values of alpha and beta. Are symmetric forms, or we say symmetric functions of zeros of px. So we can understand this easily. If any of the expression is given to us such that even on interchanging alpha and beta, the expression remains unchanged, then it is a symmetric form or symmetric function of zeros of a quadratic polynomial. Now we learn how to find out their values. The values of these symmetric forms or symmetric functions of zeros can be found out by applying the algebraic identities and then transforming them in terms of alpha plus beta and alpha into beta, because we know the values of alpha plus beta and alpha into beta without finding the values of alpha and beta. So what are those identities? Number one, suppose we know alpha plus beta whole square. We know it is alpha square plus 2 alpha beta plus beta square. It means in case we want to find out the value of alpha square plus beta square, we will transpose this 2 alpha beta on this side, and then we get here alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. It means we have transformed this in terms of alpha plus beta and alpha into beta, and then we can substitute the values of them. Second, we can see 1 upon alpha plus 1 upon beta. If we want to transform them in terms of alpha plus beta and alpha into beta, we'll take the LCM here, alpha into beta. And this will come here, beta plus alpha in the numerator, which can be written as alpha plus beta upon alpha into beta. And then we can substitute the values of these two. See the third one, suppose we are given here alpha cube plus beta cube. To find out the value of this, we know that alpha plus beta whole cube is alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. Now if we transpose this term onto this side, will we get the value of alpha cube plus beta cube? Yes. So we can write it alpha cube plus beta cube equal to alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Similarly, if we have alpha upon beta plus beta upon alpha, then also we can take the LCM alpha into beta and we find here alpha square plus beta square. And we already know the value of this from the first one, that is alpha plus beta whole square minus 2 alpha beta upon alpha into beta. So what we have seen here, that any of the symmetric form or symmetric function is given to us, we will transform this in terms of alpha plus beta and alpha into beta, and then we can substitute the values from the quadratic equation and then we can find the value of this expression or this function. Let's discuss now one example based on the symmetric functions or symmetric forms of zeros of a quadratic polynomial. The example is, if alpha and beta are the zeros of the polynomial px equal to 3x square minus 4x minus 6, then find the values of alpha square plus beta square, 1 upon alpha plus 1 upon beta, and alpha cube beta square plus alpha square into beta cube. For the solution of such problem, we will write the polynomial first. Px is equal to 3x square minus 4x minus 6. Here we find the coefficient A is 3, B is minus 4 and C is minus 6. If alpha and beta are the zeros of this, alpha, beta are the zeros of Px. Therefore, we will have alpha plus beta equal to minus b upon a, which is minus 4 upon 3, that is 4 upon 3. Alpha into beta is equal to c upon a, and that is minus 6 upon 3, or we can say minus 2. Now we will find the values of these symmetric forms. The first one is alpha square plus beta square. We know this can be transformed in terms of these two, that is alpha plus beta whole square minus 2 alpha beta. Substituting the values of these, we are getting this as 4 by 3 whole square minus 2 into minus 2. That comes as 16 upon 9 plus 4. Take the LCM 9, this is 16 plus 36, or we can say it is 52 upon 9. This is the value of the expression alpha square plus beta square. Now the second function is given to us is 1 upon alpha plus 1 upon beta. Take the LCM alpha into beta, we are getting beta plus alpha or alpha plus beta. And we substitute the values, this is 4 upon 3 upon minus 2. This 2 cancels this 2 to the 4, and this is now minus 2 upon 3 is the answer to this problem. Then we have the third function, that is alpha cube beta square plus alpha square into beta cube. What we find here? We are getting alpha square into beta square as common. And in the bracket it will come as alpha plus beta. We can also write this as alpha into beta whole square into alpha plus beta. We substitute the values. Alpha into beta is minus 2 square of this. Into alpha plus beta, that is 4 by 3, and we are getting this as 4 into 4 by 3 or 16 by 3. This is the value of this particular function. So like this, any of the symmetric function is given to us, we can find out its value by transforming them using the algebraic identities in terms of alpha plus beta and alpha into beta. In the next video, we will learn about division algorithm of algebraic expressions. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.